Good afternoon.
Good afternoon.
Someone mastering trigonometry by the age of 13, solving infinite series by the age of 14, and inventing new ways to solve higher order equations by the age of 15. All of this without any formal training in mathematics. That someone was none other than S. Ramanujan, the man who knew infinity. In a short life of just 32 years, Ramanujan changed the course of mathematics. But the man had his own share of struggle. Ramanujan was born in Madras, British India, to a very humble family. His father was a clerk in a shop and his mother, a housewife who sang at a local temple. At an early age, Ramanujan showed signs of his mathematical genius, but he struggled a lot at other subjects, often failing in them. When he was 11 years old, he was gifted a book on trigonometry. Ramanujan mastered trigonometry in just 2 years. But the book that really changed his life was the one that contained 5,000 theorems, which he studied in detail. By 16, he was developing his own theorems. Back in 1900s, mathematics was not an option to make a living in India. He showed his work to many foreign mathematicians, but all of them said that Ramanujan was unconventional and lacked a formal education. But when his work came across the desk of G.H. Hardy in England, the latter could not believe his eyes. Hardy decided to call Ramanujan to England. Hardy Hardy examined Ramanujan's work, after which Littlewood said, "I think we can compare him with the great German mathematician Jacobi." In England, Ramanujan made a great progress working with Hardy and Littlewood. Ramanujan was exceptionally good at infinite series. Before him, there was the infinite series for pi. The problem was that it was very slow. It took 600 terms to come to the value of 3.14. Ramanujan, on the other hand, developed a series that would converge to 3.141592 just after one term. After spending time with him, Littlewood told Hardy, "Forget Jacobi, we can compare him with Newton." Another famous incident that shows Ramanujan's genius was when Hardy once came to meet him. When he got there, he told Ramanujan that the cab's number 1729 was rather a dull one. Ramanujan said, "No, it is a very interesting number. It is the smallest number expressible as a sum of two cubes in two different ways. 1 cube plus 12 cube and 9 cube plus 10 cube. This number is now known as the Hardy-Ramanujan number." The best incident that is noteworthy is when Hardy came up with a scale of mathematical ability that went from 0 to 100. He put himself at 25. David Hilbert, a great mathematician, was at 80. Ramanujan was at 100. someone mastering trigonometry by the age of 13, solving infinite series by the age of 14, and inventing new ways to solve higher order equations by the age of 15. All of this without any formal training in mathematics. That someone was none other than S. Ramanujan, the man who knew infinity. In his short life of just 32 years, Ramanujan changed the course of mathematics. But the man had his own share of struggle. Ramanujan was born in Madras, British India, to a very humble family. His father was a clerk in a shop and his mother, a housewife who sang at a local temple. At an early age, Ramanujan showed signs of his mathematical genius, but he struggled a lot at other subjects, often failing in them. When he was 11 years old, he was gifted a book on trigonometry. Ramanujan mastered trigonometry in just 2 years. But the book that really changed his life was the one that contained 5,000 theorems, which he studied in detail. By 16, he was developing his own theorems. Back in 1900s, mathematics was not an option to make a living in India. He showed his work to many foreign mathematicians, but all of them said that Ramanujan was unconventional and lacked a formal education. But when his work came across the desk of G.H. Hardy in England, the latter could not believe his eyes. Hardy decided to call Ramanujan to England. Hardy examined Ramanujan's work, after which Littlewood said, "I think we can compare him with the great German mathematician Jacobi." In England, Ramanujan made a great progress working with Hardy and Littlewood. Ramanujan was exceptionally good at infinite series. Before him, there was an infinite series for pi. The problem was that it was very slow. It took 600 terms to come to the value of 3.14. Ramanujan, on the other hand, developed a series that would converge to 3.141592 just after one term. After spending time with him, Littlewood told Hardy, "Forget Jacobi, we can compare him with Newton." Another famous incident that shows Ramanujan's genius was when Hardy once came to meet him. When he got there, he told Ramanujan that the cab's number 1729 was rather a dull one. Ramanujan said, "No, it is a very interesting number. It is the smallest number expressible as a sum of two cubes in two different ways. 1 cube plus 12 cube and 9 cube plus 10 cube. This number is now known as the Hardy-Ramanujan number." The best incident that is noteworthy is when Hardy came up with a scale of mathematical ability that went from 0 to 100. He put himself at 25. David Hilbert, a great mathematician, was at 80. Ramanujan was at 100.
हाँ अच्छा बनाया तुमने।
Dr. Atul, shall we stop now? Good afternoon, sir. Good afternoon, Director, sir. Good afternoon, Director, sir. Good afternoon, Kumar Gaurav, sir.
Good afternoon, madam.
Yeah. Sir, Anil Kumar, sir, has not joined yet, and Chairman, sir, has not joined yet. I don't know.
I have just given him reminder.
Yeah.
He might be joining shortly.
Yes, yes. Madam will join expert. Professor Kusum, madam will join after 4 or 5. 4
Okay.
by she's having. Kumar sir has joined.
Good.
Kumar sir, you have to unmute. You are not audible.
Yeah. Now I think it is audible.
Yeah. Yes, sir. Yes, sir. We'll wait for Chairman, sir, Chief Guest.
Okay.
Sir, he is joining shortly, and then we'll start, sir, program. Yeah.
Good afternoon, Mr. Dixit.
Sir, very good afternoon, sir. Sir, it's very nice to get in touch with you after so many years. I have been a student of yours in the year of 2001 to 2005.
Okay, good.
When ma'am has given about you that you are there in Jhansi, so I was very excited to get in touch with you.
Same with me.
Yes, sir.
I am also delighted to see you.
Yes, sir.
Good. How are you doing?
Sir, I'm doing fine. Right now,
You are at Gwalior?
Yes, sir. Right now.
Good.
I was a student, sir, from HBDI in 2001 to 2005.
Okay, good.
So,
So you might be recognizing my face.
Definitely, sir. After this, once ma'am told me that you are from HBTI, then she gave me your name, BK Tyagi, sir. So we are very proud to hear about you, that you were the head over there, and now you are directing this institute. So it is a matter of pride for each Harkotian that he has a professors like you in his academic life.
Thank you, thank you, thank you. We'll be meeting soon.
We hope so. I hope so, sir. I will be blessed to have a physical offline meeting with you, sir.
Visit, definitely,
It
definitely.
will be blessing for me.
Good.
From 2006, I am coaching for this engineering aspirants.
Earlier you had been at Kota.
Yeah, I had been worked as a senior professor in Bunzel classes, one of the most reputed institute of this engineering aspirants for
I know.
specifically for IIT. So
I know.
then after that, FITZI is another renowned organization. They hired me for some good package, and then I worked for 11 years with FITZI.
Good.
Right now, I'm in Gwalior, running my own institute. So
good. Our chairman, sir, is also from HBTI.
Oh, that's really great, sir. That's really
He'll be
great.
joining, perhaps.
So he's of your batch only, or he may be senior?
He's my batchmate. He's my batchmate.
He's a batchmate. That's great, sir. Sir, do you know anyone of this batch, 2001 to 2005? I think you were in the oil department, na?
Yes, oil technology.
Oil technology. So, can you recognize anyone of that batch, 2001 to 2005? Do you have any of your memories?
Right now, I am unable to recollect the names, but if you name certain students, then I can recollect.
Yeah.
From oil technology.
Yeah, definitely. There was a Naveen Kapoor. He was basically Naveen Kapoor of. He was from the food technology, but he is a height of 6 feet and 3 inches tall. So he's like the renowned student of that time, 2001 to 2005, Naveen Kapoor. And in oil, there used to be Anurag Chand Dwivedi. Anurag
Dwivedi was there, yes.
Anurag Dwivedi, 2005.
Madam?
Yes, sir. Chairman sir has not yet checking his participants list. And even Anil Kumar sir has not joined, but and I tried to call him up, Anil Kumar sir, but he's not picking up the phone.
Should I call Chairman sir?
Yes, sir. If he joins, then we'll start.
Hello.
Yeah. Good afternoon, sir. Yeah.
Hello, madam.
Yes, sir. I think sir has joined.
हाँ अभी मेरी बात हो गई जॉइन
हाँ।
करने वाले कर लिया हुआ है तो
कर लिया है।
आवाज आ रही है त्यागी जी?
हाँ आ रही है वेलकम वेलकम
नमस्कार
Yes, good afternoon, sir.
गुड आफ्टरनून
Sir, shall we start, sir? Anil Kumar sir has not joined. Maybe he is not picking up the phone. We'll start, sir.
Naruka is there or not?
No, he is also not. He has also not joined.
Oh, they may join in the meantime. We can start.
Yes, sir. Yes, sir. Please.
Okay.
Pure mathematics is in its way the poetry of logical ideas. Somebody said this. Mathematics as an expression of the human mind reflects the active will, the contemplative reason, and the desire for aesthetic perfection. Its basic elements are logic and intuition, analysis and construction, generality and individuality. Somebody said this. With this, let's see what the best of the brains think about this very dynamic issue. A very good afternoon to all present here. I, Shahnaz Ayub, host of this webinar. Before inviting Honorable Director BIET Jhansi, Professor V.K. Tyagi sir, for welcome and inaugural address of National Webinar on Making Mathematics Interesting for Engineering Students, jointly organized by Innovation and Incubation Cell of our Institute BIET Jhansi and State Project Implementation Unit Uttar Pradesh under Knowledge Transfer Series to commemorate the birth anniversary of legendary, reverend, most respected Sir Srinivasa Ramanujan, Indian mathematician whose contributions to the theory of numbers include pioneering discoveries of the properties of the partition function. This day is celebrated as National Mathematics Day too. Let me take this privilege to welcome Professor V.K. Tyagi, sir, and introduce him with his permission. Professor V.K. Tyagi is director. I request all the participants to please mute their mic. Professor V.K. Tyagi is director at Bundelkhand Institute of Engineering and Technology, Jhansi, since 22nd December 2016. He earned his BTech, MTech, and PhD in Chemical Technology from HBTI, now HPTU Kanpur. He has completed research projects funded by research funding agencies like DST and AICT. He has published
लाओ
many
सर वो
research
दिए जाए, हम
papers
नाप
in
लेंगे,
reputed
नपवा के दे रहे नहीं, आपके पास टाइम ही नहीं रहता है.
national and international journals. Professor Tyagi has delivered expert talks in many seminars. He has visited foreign countries like USA and Canada. He has attended international conferences, annual meeting and expo at California, Chicago, Quebec, Phoenix, etc. He has served various administrative positions in the institute as head of the department, dean, academics, chairman, council of students, etc. He has established a center of excellence in HBTU Kanpur. Apart from his academic and administrative career, Professor Tyagi is a well-known sportsman as replicated well by his physique too. He has represented Uttar Pradesh state in National Aquatic Championship since 2012 to 2016 at Bhopal, Rajkot, Gulbarga and Hyderabad. He is throughout first ranker in annual athlete meet and run for unity and integrity organized on every Republic Day in the institute as a faculty and also as a director since his joining as a faculty in 1988. Professor Tyagi, during his tenure as director of BIET Jhansi, has done good academic and infrastructure developments in the institute. He is a multi-talented personality, continuously engaging innovative teaching learning processes and encourages his subordinates too. He strongly believes in if you really want to achieve it, the whole universe conspires to help you in achieving it. Let's wish Professor V.K. Tyagi sir for successfully completing 4 years of his contributions to BIET Jhansi as the director today. Yes, it's very much today on 22nd December. I request you, sir, to welcome the dignitaries and bless us with inaugural address. Over to you, sir.
Thank you, madam. Thank you very much. At the beginning, first of all, I would like to welcome Chairman Governing Council of this institution, Engineer Rakesh Gupta ji, who had always been stood with the development activities of this institute since he has taken over the charge of the Chairman Governing Council of this institute. I welcome you, sir. I welcome the speakers of today's webinar, Mr. Kumar Gaurav Dikshit, Director, Elite Institute, Gwalior, and Professor Kusum Deep, Professor of Mathematics at IIT Roorkee. I welcome Dr. Anil Kumar in absentia. Perhaps he might have some important work. He could not join. Might be he will be joining shortly. Who has always been kind enough to be associated with the activities related to the BIET Jhansi. I welcome Mahavir Singh Naruka ji, Nodal Officer Academics, who is also very active. Whenever we plan any activity, he comes forward for such type of activities which are of national importance. And the participants who have joined to this national webinar, which is being organized on a very important topic, that is making mathematics interesting for engineering students. That too on a very auspicious occasion, National Mathematics Day, which is celebrated in the country on the birth anniversary of great mathematician par excellence the country has produced ever, Sir Srinivasa Ramanujan. As you all are aware that mathematics is just like your spine. If you are good at mathematics, you can do miracles in the field wherever you attempt, wherever you want to succeed in the life. You have to make mathematics your very strong subject, because in the life it is all calculations, arithmetic calculations, logical reasoning, which are basic foundation stone of all the subjects of the science and engineering specifically, whether it is thermodynamics, whether it is heat transfer, whether it is mass transfer, anything, any subject you talk about. But definitely it is the role of the mathematics. If you are strong in mathematics, you are bound to excel in almost all spheres of the life. Although it was not true with Sir Ramanujan. He was very good at mathematics and he used to ignore all the subjects. He was very he was from a very poor family and he used to concentrate only in the mathematics. He could not get any formal education, but even then the contribution of Ramanujan has been taken into account by various researchers, various mathematicians across the globe. So I can share you one example. One of my friend who is superintending engineer in PWD, he is very good at mathematics. He used to share one thing with me. I would like to share with all of you that if you visit someone's house and the kids of the house comes to the dining room and they interact with the guests who are visiting you, it is a litmus test that the kids are strong at mathematics. Because normally what happens, whenever you visit or anybody visits to your house, they ask simple arithmetic questions to the kids just to keep them engaged and all that. If the kids are strong in mathematics, they normally interact with the visitors who are unknown to them. And I have found this fact in a number of the cases. So that is the strength of the mathematics. So I will not take much of your time. I welcome again all the dignitaries who have assembled on this virtual platform to be a part of this national webinar, and definitely the experts which we have, which are the part of this national webinar, they will share their experiences with the mathematics. They will let you know the different tricks which will be beneficial to all engineering students. Not only engineering students, but those students who are in class 11th or 12th and are aspiring to be in good institutions like IITs and IITs and other engineering institutions for studies. So with all these words, I am again thankful to all the organizing team, particularly Atul Dwivedi and Dr. Sanaj Ayub, who had spared their valuable time and making a good video particularly for the presentation of this particular webinar. This is again a part of the innovation, because as we are proceeding to the webinars, series of the webinars, innovations are also taking place, and this is a burning example. Today's webinar is a burning example that how we have displayed the documentary related the starting of this national webinar. With all these words, I again welcome all the participants, and I am confident that all the participants will be benefited by the expertise, by the expertise deliberations from the experts today. Thank you very much.
Thank you very much, sir. As you rightly said, mathematics is the most beautiful and most powerful creation of the human spirit. Thank you very much, sir. I wholeheartedly thank you for your inspiring and encouraging words. We wish to express our gratitude to you, sir, for being with us on this event. Your presence has always boosted our morale. Thank you very much, sir. Moving ahead, leaders become great not because of their power, but because of their ability to empower others. Honorable Chairman, Board of Governors, BIET, Jhansi, Engineer Rakesh Gupta, sir, our chief guest today. We feel proud to have with us our Honorable BOG Chairman, BIET, Jhansi. Sir, you hardly need any introduction. You have made all of us proud by your distinguished work in numerous capacities. A man of distinct vision and a fountainhead of illuminating ideas, an idol of worship, experience, inspiration to all of us. Sir is alumnus of HBTI, now HBTU Kanpur. Since 2017, Sir is chairman of BOG BIET Jhansi. These are his efforts that under his chairmanship, BIET Jhansi has progressed in many aspects. Yes, we have such a successful leader. The whole digital platform is vibrating and echoing his prominence. I request you, sir, to take this digital platform and fulfill our knowledge with your thoughts and have a close words of motivation with all of us. Over to you, sir. Yeah. Chairman, sir, over to you, sir.
खोलना जरा.
Yes.
हेलो.
Yes, sir. You are audible, sir.
आवाज आ रही है?
जी सर, बट वीडियो नहीं है सर.
अच्छा, वीडियो इसलिए नहीं है कि मैं स्टार्ट नहीं करना.
या कोई बात नहीं सर. अभी
आवाज आ रही है ना?
यस यस सर, यस सर.
वीडियो स्टार्ट कर दीजिए सर. अच्छा,
कर देते हैं.
एक्चुअली उनको बैंडविड्थ का प्रॉब्लम आ रहा होगा शायद.
नहीं नहीं नहीं.
एक मिनट.
हाँ सर, अनम्यूट कर लीजिए सर. अभी आप म्यूटेड है, अनम्यूट कर लीजिए सर.
हो गया?
जी सर, जी सर. अभी फिर अनम्यूट करना पड़ेगा सर.
अब आवाज आ रही है?
यस सर. यस सर.
थैंक यू सना जी. काफी समय आप तारीफ करने में निकालती हैं जिसकी शायद उतनी आवश्यकता नहीं है. चलिए, आज मैथमेटिक्स डे पर हमारे महान गणितज्ञ श्री रामानुज श्रीनिवासन, क्या नाम है जी, को मैं हृदय से श्रद्धांजलि अर्पित करता हूं. निश्चित रूप से जितना उनके बारे में हमने पढ़ा है, मैं कह सकता हूं कि बिना साधन के, बिना धन के भी आप चाहें तो आप अपना नाम भी विश्व में कमा सकते हैं और समाज को कुछ न कुछ दे सकते हैं. ऐसा ही उदाहरण श्रीनिवासन जी का है कि 33 वर्ष की आयु में ही उन्होंने बिना किसी डिग्री के, बिना इवन इंटरमीडिएट किए हुए, उन्होंने मैथमेटिक्स के इतने सारे शोध कर डाले जिस पर आज बड़े बड़ी डिग्री वाले, बड़े बड़े पीएचडी होल्डर्स रिसर्च कर रहे हैं. न सिर्फ भारत में बल्कि पूरे विश्व में रिसर्च चल रही है. शून्य से शून्य को डिवाइड करें, क्या मिलेगा, यह भी खोज श्रीनिवासन जी की है. जहां तक इंजीनियरिंग का सवाल है, मैं तो कहता हूं इंजीनियरिंग क्या, मैथमेटिक्स के बिना, आवाज आ रही है ना?
जी सर.
मैथमेटिक्स के बिना किसी भी देश की अर्थव्यवस्था भी संभव नहीं है. कह सकता हूं कि जीवन में भी बहुत सारी तकलीफें होंगी अगर हम मैथमेटिक्स को इस्तेमाल नहीं करें. एक अनपढ़ व्यक्ति भी अरे कुछ नहीं जानता है तो गणित का वो जरूर जानता है. वो अपना नाम लिखना नहीं जानता होगा मगर रुपया गिनना जरूर जानता है. इसलिए बिना मैथमेटिक्स के मैं कह सकता हूं कि जीवन भी संभव नहीं. इंजीनियरिंग में तो इंजीनियरिंग की एबीसीडी भी मैथमेटिक्स से ही स्टार्ट होती है. बिना मैथमेटिक्स के इंजीनियरिंग संभव नहीं है, यह तो तय बात है. परंतु आज हमें सीखना क्या है? मैथमेटिक्स, साइंस और अपने सब्जेक्ट्स पर आपके विशेषज्ञ आपको पढ़ा ही रहे हैं. बहुत सारे स्टूडेंट्स मैं देख रहा हूं इसको ज्वाइन किए हुए हैं. सीखना यह है कि कम साधन में किस तरह से हमारे इन महर्षियों ने, हम ऋषि ही कहेंगे, जिन्होंने बिना डिग्री के बिना उसके, इसका मतलब ईश्वरीय शक्ति इनके उपास थी, जिसको प्राप्त करके ही इन्होंने इस तरह की खोज कर पाई होंगी। इतनी कम उम्र में, कम साधन के साथ, बहुत गरीबी हालत में उन्होंने इतना बड़ा नाम कमाया। शायद बहुत बड़े लोग भी बहुत पैसे के साथ भी वह पद ना हासिल कर पाए हों। इसलिए मैं समझता हूं आज का दिन तभी सार्थक होगा, या उनको सच्ची श्रद्धांजलि तभी होगी, जब बच्चे साधन की चिंता किए बिना अपने पढ़ाई को तन मन धन को से लगाकर और कैसे भी अपना एक मोटो कर लें। क्योंकि मैं पढ़ रहा था कि वो जो है दूसरे सब्जेक्ट्स में फेल हो जाया करते थे, क्योंकि उनका मैथमेटिक्स, जिस भी क्लास में बैठते थे, जिस भी सब्जेक्ट की क्लास में बैठते थे, वो सिर्फ मैथमेटिक्स के बारे में सोचते थे। इसलिए मैथमेटिक्स इनका जीवन था और इस कारण से वो कर पाए। बाद में उन्होंने फॉरेन कुछ साथियों के साथ, फॉरेनर्स के साथ, शायद मिस्टर गार्डी के साथ मिलकर कुछ और रिसर्च की। तब कैम्ब्रिज यूनिवर्सिटी ने उनको बीए की डिग्री दी। तो इन सब से हमको यही सीखना चाहिए कि अगर हम अपने कर्म पर लगे रहते हैं और अपने ध्येय से हटते नहीं हैं, तो निश्चित रूप से हम एक मुकाम हासिल करते हैं। मैं चूंकि रास्ते में था और समय हो गया था, इसलिए मैंने अपनी गाड़ी में ही इसको खोल लिया और मैं शायद ज्यादा समय नहीं दे पाऊंगा। धन्यवाद, सबका स्वागत। मुझे लगता है जो एक्सपर्ट्स इसमें आए हैं वह बहुत अच्छे से आप लोगों को मैथमेटिक्स और इंजीनियरिंग का कॉम्बिनेशन बता पाएंगे। जय हिंद, जय भारत।
थैंक यू सर। या कोटि कोटि धन्यवाद सर। हमें बहुत खुशी होती है, हम बहुत गौरवान्वित फील करते हैं कि आप हमारे लिए टाइम देते हो और हमें अच्छा लगता है। हर बार हमारे पार्टिसिपेंट्स जो है वो अलग अलग होते हैं, क्योंकि टॉपिक अलग अलग होता है, तो हमें अच्छा लगता है कि हम अपने,
मुझे अच्छा लगता है कि आप लोग हमें इनवाइट करते हो। मुझे अच्छा लगता है कि आप जो है मेरी भी नॉलेज बढ़ती है।
थैंक यू सर, थैंक यू सर, थैंक यू वेरी मच सर। Mathematics has been regarded as a fundamental subject because arithmetic and logical reasoning are the basis of science and technology. For this reason, educational authorities emphasize students' proficiency in computational skills and problem solving. Conventional teacher-led instruction remains dominant in most elementary mathematics classrooms. Under such instruction, the teacher can rarely take care of all students. Many students may then continue to fall behind the standard of mathematics achievement and lose their interest in mathematics. They eventually give up on learning mathematics. There is geometry in humming of the strings. There is music in the spacing of the spheres. Legendary Pythagoras said this. And yes, we have another mathematician as an expert today, Engineer Kumar Gaurav Dikshit, Director, Elite Institute, Gwalior. Graduated as BTech from HBTI, now HBTU Kanpur, has served as a senior professor of mathematics at Bansal Class Coaching Kota, one of the most reputed names in coaching for IITG and other engineering exams. Thereafter, Engineer Dikshit served as head of the department Mathematics in FITG, Delhi. He is also an active member of American Mathematical Society, presently running his own institute, Elite, in Gwalior as Elite Institute, mentoring students for IIT G Mains, IIT G Advanced, Kishore Vaigyanik Protsahan Yojana, National Talent Search Examination, Indian Statistical Institute, Indian Institute of Science, Education and Research. His students have done and are doing engineering from reputed institutes like IITs and NITs. I request you, sir, to take this digital platform and fulfill our knowledge. We are honored to listen to your insightful speech as an expert to motivate this galaxy on the topic, making mathematics interesting for engineering students. Over to you, sir. We almost have more than 260 participants on this Zoom platform and many more on live interactive streaming to listen to you, sir. Yeah, sir, please unmute, sir.
Madam, he is not audible.
Is it audible now?
Yes,
Yeah, now
yes,
it is
yes, now
audible.
audible.
Now it is audible.
Thank you, Shahnaz ma'am, and thank you, our respected VK Tyagi sir. Thank you, Rakesh sir, for providing me the opportunity to express the knowledge which I have amassed through this long years of experience through various platforms, whether they are in Kota or in Delhi. So actually, just recently our respected Tyagi sir has said that mathematics is the spine of everything. In more technical words, I would like to say that mathematics is also called as queen of sciences. Mathematics is basically literally known as queen of sciences. Every kind of scientific aspect, whether you are involved in, always involves mathematics. Now, the basic motive of us that we are here to make the mathematics more interesting. Basically, the main goal of most of the teachers as well as the students is to make the mathematics interesting part, because most of the time we feel like mathematics is quite boring. So this is a really important part, that when we go for maths is something, if you are started having a feeling of the subject, then it becomes really very interesting. It is one of the most interesting part of the whole sciences, or you can say it is the most interesting part of the whole life, because just like our Rakesh Gupta sir said that ki आपको कुछ आना चाहिए, ये नहीं आना चाहिए, मैथ्स तो आपको आती ही होगी और आनी भी चाहिए, क्योंकि अगर आपको रुपए कमाने हैं तो रुपए गिनने तो आपको आते ही होंगे. So this is the mathematics is undoubtedly is the most important part of life, but for that you have to develop the interest. Develop interest means mathematics, you cannot say it is a only of addition, subtraction, multiplication, division, or you can say coordinate, algebra, trigonometry. Mathematics is something beyond that, which we call as, it's a study of patterns. Mathematics we try to study the patterns, like Ramanujan, our respected Ramanujan, who is the most remarkable mathematicians of in the history of mathematics of our India. He has studied the patterns of natural numbers. He's one of the most remarkable theory. He said that the sum of natural numbers, he proved that sum of the natural numbers comes out to be -1/12. So basically what we try to feel the essence of mathematics, when we are interested in feeling the concept of mathematics, we have to analyze the patterns over there. The patterns in mathematics. The patterns in mathematics means, let me begin with something. Here I have.
Yeah, you can share the screen, sir.
Yeah, we have this.
Yeah.
Ma'am, please enable this screen sharing.
Yeah, sir, you are co-host, so it is enabled. Screen sharing is.
Yeah, it is enabled. Yeah, fine. Yeah. So we have this. It is. Okay. So actually, the essence of mathematics means that whenever we are trying to understand the nature, whenever we are trying to understand the concepts of natural phenomena, they can only be understood with the help of mathematics. We call the mathematics as a queen of sciences. You can see the Galileo Galilei in the 17th century said that nature cannot be understood unless one first learn to comprehend the language and read the characters in which it is written. It is written in the language of mathematics, and its characters are triangles, circles, and other geometrical figures, without which is not humanly possible to understand a single word of it. So whenever you are interested in making mathematics as one of your favorite subject, then it becomes very important that you try to understand the language of mathematics. The language of mathematics is basically written with the help of the characteristics like numbers, triangles, circles, and various other geometrical figures, which we will go through in this whole presentation. Now, the very first, then there comes a scientist whose name was Blaise Pascal. He gives another study of numbers. See, whenever we are interested in making mathematics worth interesting, the whole thing depends on number system. The whole thing depends upon, even in the recent research also, even recently, you may be excited to know that there is nothing kind of a system where we can define the prime numbers. We have no format to define a prime numbers. Means prime numbers are those numbers only we can say that which is divisible by 1 or they are divisible by itself. That's only we can say about prime numbers. There is nothing, any kind of a format or relation in which we can define or we can generalize prime numbers. Until now, there are many researches yet to be conducted and is going on, of which one is we have prime numbers. We do not have any kind of a generalization of prime numbers. Like we can generalize even numbers. Even numbers can be generalized with the help of 2n. Odd numbers can be generalized with the help of 2n minus 1 or 2n plus 1. But the prime numbers are yet to be given a generalization format. So there are many things which is yet to be discovered. And even all of, like we have budding engineers over there. So you all have the opportunities still in the number theory. There are a lot of researchers. Even nowadays, the Olympiads which are being conducted, either in 10th, 11th, or in the senior level also, they always tends to ask either the questions of number theory or the questions of geometrical figure. So now in this case, this is Pascal's triangle. This is a rectangular arrangement of elements. This was invented by Blaise Pascal, and it is a very systematic pattern. See, maths has two different aspects. One aspect is, we call it as addition, subtraction, multiplication, and division. That's a very basic concepts. That is only for you can say up till 8th or 9th level. But now you are a budding engineers. Now you are all are future engineers. So you must have to develop an interest towards the format of numbers, the pattern of numbers, just like Blaise Pascal developed. He created a this kind of a triangle, which we call as Pascal's triangle. Now you can see in this Pascal's triangle, we have this, you can see that in Pascal's triangle, we have this arrangement, and in this arrangement, there is one on the each side, in each length, there is one. And in this, we have 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. If you can recall your memory, the power of 11, 11 raised to 0 is 1, 11 raised to 1 is 11, 11 raised to square is 1, 2, 2, 1. So one of the feature of this Pascal's triangle is, whenever you are trying to recall how this power of 11 goes, you can easily recall from here, first thing. Second thing, whenever we need to have the expansion of binomial, you may have all gone through binomial theorem, or we can say binomial term, or we can say binomial expression. So whenever we have that a plus b the whole square, suppose we have a plus b the whole square. So in that case, when we have a plus b as a whole square, we have a square plus b square plus 2ab, or you say a square plus 2ab plus b square. In that case, we can see that these are the coefficients 1, 2, and 1. This is 1, 2, and 1. So these are the coefficients, a square, then 2ab, then b square. For sake, you have a plus b the whole cube, a cube, then 3ab square, then 3a square b, then b cube. So these are also can be treated as the coefficients in the expansion of binomial theorem. So this is a pattern which Blaise Pascal developed. Now, the pattern, since we are mainly we are interested in creating maths as an entertaining or as an interesting part. So there must be a pattern of numbers. Pattern of numbers means, or you can say pattern of geometrical figures. Pattern of geometrical figures, when we talk about the pattern of geometrical figures, we have a geometrical figure over here. You can see there are parallelograms. You can see these are the two figures. These are the two set of parallel lines. These are two set of parallel lines. Now, everyone is basically, when we see these set of parallel lines, we have an interest that how many parallelograms should be there. How many parallelograms should be there? Whenever we have this kind of a parallel lines, the first curiosity arises in our mind is that how many parallelograms are there. So can any one of you recall that how many of the parallelograms are over here? See, in this figure, if you are little aware about the numbers, then we can have the number of parallelograms over here as we will be having 1, 2, 3, 4, 5, and 6. 1, 2, 6, 6, 5, 30 over 250. 1, 2, 3, 4, 5, 5, 4, 20, and 10. Now, can you imagine the number of parallelograms over here are 150 parallelograms are here. Now, this is a study of geometrical figures. This is a study of patterns. Now, when we come to study of geometrical figures, or when we come to study of patterns, there is another important term which we call it as golden ratio. Golden ratio. This is a very, very miraculous ratio, golden ratio. So I would like to add this golden ratio. We have this, it is annotate. This is what we have is golden ratio. So,
Okay, so I'm going to explain in this video a math and design phenomena called the golden ratio. It's also referred to as phi, ratio 1 to 1.6.
And this is the ratio that's called the golden ratio, a 1 to 1.6 ratio. So this is what the golden ratio looks like as a rectangle, 1 to 1.6. And if we were to start making incremental golden ratio points within that, we can get an idea of what a spiral looks like when it expands outward at the same measured sequence. Now this is all well, and now let's take this closer to home. I want you to hold out your arm and look at the distance between your shoulder and your elbow, and then from your elbow to your fingertips. Notice how your elbow, from your shoulder to your elbow is 1, and then from your elbow to your fingertips is 1.6. Pretty crazy, huh? But it doesn't stop there. Now take that further. The distance from your fingertips to your wrist is 1, and from your wrist to your elbow is 1.6. Keep it going. From the furthest tip of your finger to the bottom of your fingers is 1, and from the bottom of your fingers to your wrist is 1.6.
Now, see, I would like to add one thing. What is basically a golden ratio? A golden ratio is basically a ratio of two numbers. A ratio of two numbers in such a way whenever we are trying to design anything in a perfect way, whenever we are trying to design everything in a perfect way. For example, we may have gone through many peoples which are very tall, and their body posture is something like their upper part is small relatively with their lower part, lowering the upper parts, and it looks awkward, like iski to tange hi badi hai. But this golden ratio, this is a perfect ratio which defines, which creates what is ideality. How do we proceed? In many times we have a doubt in our mind. So how do we define a perfect figure, perfect, or you can say anyone? So like in many of the cases, you may have seen that many of the students or many of the peoples used to have smaller fingers relatively with their palms. So it seems like in general, it is not an issue, but whenever you go for a more precisely monitoring those fingers, those palm, you will say, "Arey, tumhari ungaliyan choti hain." तो वो एक उंगलियां छोटी हैं या उंगलियां बड़ी हैं, तो that ratio is that ratio which enables to give the perfect figure of a palm, or you can say of your hand, or you can say any of thing. So that comes from a math.
Now check out the spacing of your knuckles, 1 to 1.6. Are you getting freaked out yet? Think about this. The head to your belly button, 1, and then belly button to your feet, 1.6. From your toes to your knees, and from your knees to your hips, golden ratio. Ever wonder why your 2 front teeth are so much bigger? Golden ratio. The pupils of your eyes, I mean, you name it, your whole body is the symphony of the golden ratio. In fact, as you are listening to this video, the sound waves are passing through your ear in a perfect golden spiral.
So now we have the fundamental strategy that how should we proceed while practicing maths. So there is a development of interest towards maths. How should we proceed so that we have a great interest towards doing maths problems, or we are in a position to excel the marks in subject of maths or any subject related with mathematics. The first thing which comes in the fundamental strategy is practice, practice, and more practice. There is no substitute. Maths means it is practice, and practice with the help of pen and paper. Many times the students, whether they are in an engineering format or they are in a below engineering, whether they are preparing for engineering aspirants, they are in a position just like they hold the book and start reading it. No, reading never gives a perfection. You have to practice with the pen and paper. Then comes review your errors. Then when you practice, then you have to analyze your errors. Until and unless you do not find the errors in yourself, you cannot upgrade yourself. So second, the important point is review your errors. Errors makes you more errorless. Then we have master the key concepts. Now, the key concepts, every subject, and you can say topic under the every subject has various important key concepts which are to be excelled by you. Once you excel the key concepts, then started developing your own vision about that thing. मतलब बच्चों की अपने विजन होता है. कई बार मैं I am teaching for the last 18 years, 16 to 18 years. I found in various topics, like you may also have gone through permutation, combination, or you may have gone through probability. Now, in PNC and in probability, many times the students give more better solutions than teachers. So you should have your own vision of understanding the question. And in case you find that your vision may not be, your question may not be up to the mark, never hesitate about that. There should not be any kind of hesitation. If I will ask to sir, what sir will think of myself, and he will think कि इतनी छोटी सी बात क्यों पूछ रहे हो, ये सारी चीजें दिमाग में नहीं होनी चाहिए. Then whenever you are practicing for maths or you're practicing for any kind of studies, create a distraction-free study environment. You should have a distraction-free study environment. Means there should be a utter peace, utter silence, absolute silence, we can say, where you can concentrate on yourself, on your you can focus yourself. Then we have try to create a mathematical dictionary. Mathematical dictionary in a nutshell, I must say, when we are focused for a mathematical dictionary means you ought to have the summarized results of each topic. You ought to have the summarized results of each topic. For example, whenever you are going for algebra, then you must have the whole algebra in 2 to 3 pages. The whole entire algebra summarized in 2 to 3 pages. So whenever during the exams, in the just before exam, then you need only 2 to 3 those pages to finally revise all the concepts of algebra. Or when you can go for like coordinate, or you go for any engineering mathematics. In engineering mathematics, there is Maclaurin series, Taylor series. So the most of the part of engineering mathematics based on Maclaurin and Taylor series. So you just have to write it down, those series, either in your study room or in kind of a dictionary format as per your comfortability. Then when you are interested for creating your personality for maths, when you are interested for creating yourself as a the great personality of maths, then apply maths to the real world problems. Just the Ramanujan was there, and most of the any great mathematicians, he always have a habit of applying maths to the real world problems. Many of the times I have learned that people used to add up the numbers of the vehicles whenever they move, whenever any vehicle come in front of them, they used to add up those numbers. So apply these kind of simple mathematical strategies to these kind of real world problems. Now, there is also a concept, we call it as Vedic Maths. I also used to teach Vedic Maths. Vedic Maths is what? Vedic Maths is a part of maths which was introduced by our rishis, our saints, and they have introduced the various fastest way of calculations, various fastest way of multiplication, various fastest way of division, various fastest way of performing various other operations. So go for application of maths to real world problems. Then we have learn to work by the clock. Now, this is another important thing. Learn to work by the clock means you should have an accountability that how much time you are devoting. There should be accountability of everything. There should be accountability of everything means how much time you are devoting. Means in many of the cases you feel that you have devoted the whole day. In many of the cases you feel that you have devoted the whole day, but in a nutshell, when you take account, it comes as only 2 to 3 hours. So it should be very clear that there should be accountability that how much time you are devoting and how much efficient it is. How much efficient it is. This is another important. Efficient means many times बच्चे क्या करते हैं, पूरे दिन किताब खोल के बैठे रहते हैं, बट फाइनली एट द एंड ऑफ अ डे अगर कंक्लूड किया जाए तो उन्होंने कुछ भी नहीं किया. तो लर्न टू वर्क बाय द क्लॉक मींस आप जितने भी घंटे पढ़ रहे हो उतने घंटे आपको बहुत ही ऑनेस्टली फोकस्ड वे में एक डिस्ट्रैक्शन फ्री स्टडी एनवायरनमेंट में पढ़ाई करनी है, एंड देन रेस्ट, फॉरगेट इट, एंड देन मूव टू द अदर पार्ट्स ऑफ योर daily work. But in that daily work also try to include maths as per your efficiency. Then revise through questions. Now comes ki in many times ki sir maths में जैसे सर जब समझाते हैं तब समझ में आ जाता है लेकिन बाद में फिर नहीं होते हैं. तो जो क्वेश्चंस आपने पहले किए हैं उनको रिवाइज करवाओ. The more you revise, the more you start developing your own perception about that. देखो, एवरीथिंग डिपेंड्स ऑन योर ओन परसेप्शन कि आप उस क्वेश्चन को कैसे परसेप्ट कर रहे हो. टीचर ने लिखाया, आपने रट लिया, नहीं. जब आप टीचर के लिखाए गए क्वेश्चंस को खुद करोगे, रिवाइज करोगे, फिर खुद करोगे, फिर रिवाइज करोगे, तो यू स्टार्टेड डेवलपिंग योर ओन परसेप्शंस अबाउट दैट क्वेश्चन. तो रिवीजन इज वेरी इंपॉर्टेंट. Solve sheets from different chapters that take 2 hours time to slot for each subject. Now this is important. जब भी हम बैठते हैं, most of the time students have like कि बैठ गए और 10 मिनट बैठे फिर उठ के कहीं और चले गए, फिर 10 मिनट बैठे फिर कहीं और चले गए. नहीं, this is not a right habit to study maths, specifically for maths. क्योंकि maths needs a consistent devotion for at least 2 hours. जब आप 2 घंटे वहां बैठोगे, then next point we have, our approach should be make solution as simple and as quick as possible. Now जब भी हम मैथ्स में बात करते हैं, now this is a difference between a competitive teacher and a conventional teacher. Conventional teacher क्या होता है? Conventional teacher has a habit of giving the solution of the question. He is not focused to minimize the time for doing that question, and he is not focused also to give the best possible solution. He is only जो उसने रटा हुआ है. He is only giving you which he has mugged up by himself. So, but you are being the another genius of this coming time, and in that case you have to develop a habit of yourself to minimize and simplify the solution given by any teacher. कि what something I can add on the solution. मैं क्या कर सकता हूँ इसमें. हमेशा देखो, हमेशा जो इंसान बड़ा बनता है वो अपनी वजह से बनता है, because of himself. वो उस पे काम करता है, वो उस पे मेहनत करता है. एक टीचर, जैसे आई हैव टॉट thousands of students, Many of them have not qualified, but many of them are in the IITs and the various other engineering institutes with a very good ranks. Under 100, there are many. Not because of not because of me. It is because of themselves only. They have percepted the question. They have percepted the content given by me in their own way. They worked hard. They developed their own habits. And finally, they are in the successful life. Many of them are doing the jobs even now. So our approach should be to make solutions as simple and as quick as possible. See, both things are very important. Nowadays, doing a question is not important. Doing a question in the least possible time is important. Remember one thing, doing a question is not so important. Doing that question in the scheduled time is important. Now, as a student, you must be curious, looking for new ways to learn and do same questions in different ways. Obviously, a good student, एक जो अच्छा बच्चा है, जो अपने आप को अच्छा assume करता है कि मैं अच्छा बच्चा बनना चाहता हूँ, उसके लिए बहुत जरूरी है कि he must be curious. Curiosity is very interesting personality trait. ये personality का एक बहुत अच्छा part है कि you should be curious. You should be curious to develop various new methods along with the method given by your teacher. Any of your mentor, if any method is given by your mentor, you have not to confine yourself till there only. You have to enhance from there. कि नहीं, क्या मैं इसका और कोई सॉल्यूशन ढूंढ सकता हूं? क्या इसमें से कुछ और निकल के आ सकता है? क्या इसमें से कुछ और निकल के आ सकता है? You always thrive for best. You always strive for best. You always go for best. मेरा एक स्टूडेंट था, he was selected for ISI Bangalore, Indian Statistical Institute Bangalore. When he went there, Indian statistical institutes होते हैं, these are institutes which are basically created for data analysis and presentation. You may have gone through statistics during your preparation time. Statistics means analysis, presentation of data. But when in the very first year, he realized that he is not up to the mark here. This institute is not defined for him. He left the institute and then he went for a Delhi University, and now he's doing good over there. So even in many of the cases, Delhi University, I think St. Stephen College is there. So he's doing he's doing very good over there, and he's considered as a mathematics. He is treated as he has won various medals for fastest calculations. Like there was a Shakuntala Devi. You may have gone through the name Shakuntala Devi. Shakuntala Devi is a great mathematician, and the greatness of her lies the time and how fast he is doing the calculations, how fast she did the calculations. Therefore, she is also called as a fastest human calculator of world also. There are many books of Shakuntala Devi. So those calculations actually based on the tricks of Vedic maths. Calculations needs two things. The fastest calculations needs two things. One, the peace of your mind. Second, the strategies, tricks, which is we call as Vedic maths. So even if you are studying and all of you are here in the engineering college, you must go through some basic concepts of Vedic maths. They will help you in all the phases of your life. Then last, I would like to add, try to avoid the emotional drift towards the subject. Now, emotional drifting, see, emotionally, whenever you are emotionally weak for anything, whether you are parents, whether you are for anyone, emotionally drifting reduces your efficiency. Emotionally drifting reduces your efficiency. Emotional drifting may tend you towards going for work hard, but it somehow it controls your mind. When you are emotionally drifted for anything, then that means it is controlling your mind. So never try to control anyone, never try to handle anyone with your mind. So try to avoid emotional drift over the subject. Be very practical instead of emotional. You have your mind as free as possible. Now, begin with, like Ramanujan said, that any equation is only meaningful when it expresses the feelings of God. Ramanujan is very attracted, very, you can say, very, he was very devoted towards God. He was very devoted towards God. Even many of the these great mathematicians always believe that there is something called as divine power, and you too have to believe that there is something called as a divine power. So he once said that the theory of equations, all those equations are meaningless until and unless they expresses the wishes of a God. So one of the equation I am giving over here is, suppose this equation is there, and when we go through it, when you go through it, you will realize that when you go through it, all of this is one of the basic equation you all may have gone through in the last 1 or 2 years. And when you go through it, you may feel that the answer of this equation is x is equals to 1. The answer of this equation is x is equals to 1. But let me give you a very important thing, that the x is equals to 1 cannot be substituted in the main form of this equation. We cannot substitute x is equals to 1 in this equation. We cannot substitute x is equals to 1 in this equation. So finally, this equation is of no use, or you can say this equation do not have any solution. This equation do not have any solution. So this is through the help of this equation, what I'm trying to give you is, with the help of this equation, what I'm trying to give you is, कि whenever you get the answer of any equation, when you solve it, you will get the answer 1. See, answer जो दिख रहा है जरूरी नहीं वो वैसा आंसर होगा. इसलिए जब भी आपके पास किसी भी मैथमेटिकल प्रोसेस में, किसी भी मैथमेटिकल, you are in the engineering sector or somewhere else in the future of your life, whenever you got your answer, please do try to verify it. जब आप x is equals to 1 इसमें रखोगे तो आप you will realize that in the denominator there is x minus 1. And since in the denominator there is x minus 1, you cannot put x is equals to 1. Therefore, the answer of this equation is no solution, none. Now, I have another equation over here. And if you can feel, this equation is a quadratic. This equation here, x is a variable and a, b, c are constants. Here we have x as a variable and a, b, c are constants. I repeat, we have x as a variable over here and a, b, c are constants. Now, see, when you judge the format of this equation, you will find that it is a quadratic in x. When you judge the format of this equation, you will find that it is quadratic in x. Just try to analyze. These are some uniquely very, very good conceptual applications of maths. And through these equations, I am trying to develop a feeling inside you is that something which seems to be easy is not easy at all. With the help of these equations, I'm trying to develop a feeling inside all of you is something which seems to be easy is not easy at all. There is nothing easy in this world. Everything which seems to be easy comes out to be more complicated. So always have your minds open, always have your this dedication, devotion, determination at extreme, and have your senses up to date, have your IQ level up to date. Just we move on to this equation again. See, this equation, you can realize this equation is a quadratic in x. Undoubtedly, it is a quadratic in x. Variable is x over here. Fine. Now, any quadratic equation, it is well known that any quadratic equation cannot have more than 2 solutions. Or I must say that any quadratic equation will have only 2 solutions. Will have only 2 solutions. It is not possible that a quadratic equation is having 3 solutions. It is not possible that an equation of degree 2 is having 3 solutions. Fine, that's very true, sir. It is not possible. Now, see, in this equation, when you substitute x is equals to a, in this equation, when you substitute x is equals to a, in the very first part, when you substitute x is equals to a, the first part becomes 0, third part becomes 0, and second part becomes 1. So we have a minus b over a minus b, a minus c over a minus c, and we say that 1 is equals to 1. That's very clear. So we are having x is equals to a as a solution of this equation. We are having x is equals to a as a solution of this equation. Fine. Now, noted, there is a one solution, we call it as x is equals to a. Now put x is equals to b over here. When we put x is equals to b over here, we will see that the first part, x minus b, this is b minus b, this is 0. And second part is also 0, b minus b. But in the third part, we have b minus c over b minus c and b minus a over b minus a. The third part is 1. So 1 is equals to 1. Oh my God. That means we have x is equals to b as a solution to this equation. Yeah, that's very true. That's very clear. Now, put x is equals to c. Put x is equals to c. Now, note it. We already have two solutions over here. One solution we have find x is equals to a. Second solution we have find x is equals to b. Now, put x is equals to c. Now, when we put x is equals to c, in the second part becomes 0 and third part becomes 0. But in the first part, we have c minus a over c minus a, c minus b over c minus b. That is 1. 1 is equals to 1. Oh my God, this is again. That means it is a quadratic in x. You can easily see. All of us are somehow gone through this part of basic maths. All of us have gone through this basic maths. So you can easily find that undoubtedly, that's very clear. This is a quadratic in x. And it is having three solutions. X is equals to a. That's very clear. X is equals to b. No doubt, sir. X is equals to c. That's very true. Now this is miracle. This is again, we can say it is the 7 wonders of the word. 7th wonder, 8th wonder of the word. 7 wonders are already there. This is 8th wonder of the word that any quadratic equation is having three solutions. That's miracle. So this is not actually miracle. This is conceptual parts. See, whenever we are trying to excel in any of the subjects, whether it is maths, whether it is engineering maths, whether it is, you can say, any phase of your life, you must have your concepts very clear. Concepts means fundamental concepts. Actually, I used to give the coaching for this competitive environments, for competitive exams. The difference of selection and rejection lies in the clear of fundamental concepts. So all of you may have gone through these kind of things, but if you are not up to the mark in your fundamental concepts, your fundamental concepts are not strong, you cannot have a feeling of neither in maths nor in any subject. So maths is a very, as our respected Tyagi said, that maths is the spine of everything, spine of the whole system. Maths means maths comes in commerce also. Maths comes in every phase of your professional work. Every phase of your professional work, there is a maths. So you need to have the strong fundamentals in maths. So I would like to stress this equation has three solutions. Now it is not possible that this equation has three solutions. The reason behind this lies. I will give you in detail. Now, then we have this. Now, there comes another great question. Fundamentally, very interesting question. This is, we have 2, x to the power of 2 is equals to 8. Now, x power of 2 is equals to 8. When we have this x power of 2 is equals to 8, x power of 2 is equals to 8, we are focused in finding the value of x. Now, the important thing is this, we are interested in finding the value of x. Now, I think all what can be the value of x? 2 raised to 1 by x. We say that this is 2 raised to 1 by x is equals to 8. We say that this is 2 raised to 1 by x is equals to 8. When we have 2 raised to 1 by x is equals to 8, so when you calculate, you will find that x is coming out to be something. It is actually 1 by 3. It is actually 1 by 3 when you 2 ki power 1 by 3. 2 ki power 1 by x is equals to 8. Then you can find either x is 1 by 3 or something. So you may be having answer A, B, and C. But let me tell you one thing very frankly. The answer of this equation is neither A nor B and nor C. The answer of this equation is neither A nor B nor C. And to be very honest, you maybe not knowing behind the you may be not knowing the reason behind this concept. So this is again fundamentally things that is very important. Now another thing, many times when I was even nowadays also I am working on this, and I have done this practical many times. Suppose you have been given a stick of length L. This is a practical maths, and engineering maths, you can say engineering maths or practical maths, any kind of. Suppose you have been given a stick of length L, which is broken into 3 pieces. You have been given a stick of length L, which is broken into 3 pieces. What is the probability that those broken 3 pieces will form a triangle? No, it is not 1. It is not 1, because many times when you break that stick into 3 pieces, जब आप उसको 3 टुकड़ों में बांटोगे, जरूरी नहीं कि ट्रायंगल ही बने वहां पर, बिल्कुल जरूरी नहीं ट्रायंगल बने वहां पर. ये भी हो सकता है ट्रायंगल तभी फॉर्म होगा जब वो ट्रायंगल इनइक्वालिटी को फॉलो करेगा, और ट्रायंगल इनइक्वालिटी वो होती है जब 2 साइड्स का सम तीसरी साइड से ज्यादा होता है. Whenever we have sum of 2 sides greater than third side, then only we have the triangle inequality. This is a very natural phenomena. You can also practice it in your hostel, in your any of your part, wherever you feel. So the stick of length is broken into 3 pieces. What is the probability that those broken 3 pieces will form a triangle? I will wait for your answer, and you can give your answer over here also. So neither it is 0. It is not 0 at all. 0 bhi nahi hoga iska answer. Now, so we have this. Now, here comes another. See, calculus. Calculus. I have introduced one thing. Calculus is also called as the, you can say, mother of engineering maths. Calculus is many times considered as the mother of engineering maths. So I have introduced one question of calculus over here. I have introduced a conceptual and fundamental question of calculus over here. And it is given that y is equals to x plus x plus x plus x times. See, these all the questions which I have introduced in this presentation are basically giving you an indication, basically instructing you that whenever you are interested to excel in maths, always think of fundamental concepts. Always think of the more proof. Always go for proof. Anything you have been taught by your mentor, whenever I used to teach anything, I always begins with the proof. I always begins with the proof. तो यही मैं आप लोगों से भी रिक्वेस्ट करूंगा, सजेस्ट करूंगा कि जब भी आप मैथ्स में या कहीं भी in any subject you are being taught anything, since maths is a very practical subject. See, in chemistry or in some other topics, I cannot say about that, but whenever we are in maths, there lies a proof of everything. So whenever you have been taught any theorem of mathematics, just go for the proof. Like we have over here, the question is y is equals to x plus x plus x times. Means this expression is, we are adding this variable x to x times. And someone wants the value of dy over dx. I want the value of dy over dx. Now, this question I usually take in the beginning of my lectures for dropper section, or many of my presentations which I used to give for the engineering students, whether they are engineering aspirants or whether they are engineering students. So I used to ask the question everywhere whenever I go for this kind of a presentation. So y is equals to x plus x plus x. We are adding this to x times, and I need to find the value of dy over dx. And I hope जो बच्चे अच्छे होंगे, जो बच्चे normally everyone may be very well known about the kind of a differentiation. Many of the people used to say the answer is x. Many of the students say the answer is x because they literally differentiated. They literally differentiated 1 plus 1 plus 1 plus 1 and so on x times. And they conclude that, sir, since we are differentiating it, 1 plus 1 plus 1 plus 1 x times. So we are adding 1 to the x times, and therefore answer is 1. Now, the second approach. The second approach comes in this way. They used to take x common. They used to take x common. When you take x common over here, I think annotation is not working over here, but still I can give you a feeling of that. When you used to take x common over here, then there will be 1 plus 1 plus 1 plus 1 x times. So bi will be becoming like a function of x square. When you take x common, so there will be 1 plus 1 plus 1 x times, and bi will be like a function of x square. So when we have bi as x square, naturally the d by x, d over dx is 2x. So now we have two answers in front of us. The first one, which is being obtained by literally differentiating, by just differentiating 1 plus 1 plus 1 plus 1 plus 1 plus 1 and so on, and that answer comes out to be x. And second question, second approach says that we have taken x common in the basic function. We have taken x common and we are adding 1 plus 1 plus 1 plus 1 x times. So we have x square. Now, when we have the first part, we have answer dy over dx, which is equals to x. And in the second part, we have dy over dx is equals to 2x. Now the dilemma lies, which is the answer? Either it is x or it is 2x. Now, let me make you very clear, students. The answer of this question is neither x nor it is 2x. The answer of this question is neither x nor it is 2x. Now, sir, then what is the answer? Then the natural curiosity is, sir, I have thought x, and someone saying, sir, I have thought 2x. But let me make you one thing very clear. The answer of this expression, the answer of this question is neither x nor 2x. So the curiosity, the answer to the curiosity of yours will be solved in the you may be having my email and all. So you will be given that something over there. But answer of this is neither x nor 2x. Even you can also find the answer when you go to the basic and fundamentals of your calculus, mathematics. Calculus is the mother of engineering mathematics. So you have to make it very perfect in a basic fundamental way as well as in a competitive way. Now we have this. Now another thing, we have x cube sine inverse x with respect to x. Now in this question, actually he is interested in finding the third derivative of this. Now this is a very interesting part of the calculus. Again, this is a very interesting phenomena of calculus. X cube sine inverse x. Now x cube sine inverse x. Now in calculus, you may have gone through that a derivative of even function is odd function. A derivative of even function is an odd function. Whenever we have sin x kind of function. आज के समय में जो research work है वो basically maths में number theory पे चल रहा है. मैं आपको बता देता हूँ कौन से parts पे चल रहा है. Number theory में अभी तक prime number को generalize करने का कोई भी formula नहीं बना. आप बना सकते हो. Number theory में 7 की divisibility by 3 लोगों को पता है, 4 पता है, 5 पता है, 6 भी पता है. 7 की divisibility का भी अभी तक कोई बहुत standard formula नहीं बना है. Even some people have claimed that they have developed, but अभी वो ऐसा बहुत ज्यादा अभी उस पे मतलब उसको light में नहीं आया है. So there is a lot of work to do in the number theory as well as geometrical parts of mathematics. So that's all I would like to add in this presentation. You have this email ID over here. You have this contact number over here. And that's all I would like to add. Always believe in yourself. Fine. This is the last thing which I would like to say, that कि हिंदी में कहते हैं मन के हार है और मन के जीते जीत. तो आपको हमेशा believe ये करना पड़ेगा कि you are best. Whenever you believe that you are best, definitely one day you will prove that you are the best. So you always have to believe yourself then only you can achieve the great success which you dreamed of. Thank you, ma'am.
Yeah, thank you so much, sir. Just let me see whether madam. Yeah, sir. Madam, Professor Kusum madam has joined. Professor Kusum madam.
Hello.
Yeah. Let me thank Engineer Kumar Gaurav Dikshit sir, and then we'll proceed, madam.
Yeah, fine.
Yeah. The only way to learn the mathematics is to do the mathematics. You advise this, sir. I need to multiply thank you word 1,000 times to match it with your efforts. Thank you for being with us today with active involvement and guidance. I wholeheartedly thank you for your inspiring, encouraging, thought-provoking address. Now, let's proceed further. Without mathematics, there is nothing you can do. Everything around you is mathematics. Everything around you is numbers. As said by Shakuntala Devi, great mathematician, she too says. Yes, our expert today, Professor Kusumdeep, eminent professor, Department of Mathematics, IIT Roorkee. Dr. Kusumdeep is a full professor with the Department of Mathematics, Indian Institute of Technology, Roorkee, India, and visiting professor, Liverpool Hope University, United Kingdom, and University of Technology, Sydney, Australia, with BSc Honours and MSc Honours, School from Centre for Advanced Studies, Punjab University, Chandigarh. She is an MPhil gold medalist. She earned her PhD from IIT Roorkee in 1988. She has been a national scholarship holder and a postdoctoral from Loughborough University, UK, assisted by international bursary funded by Commission of European Communities, Brussels. She has won numerous awards like Khosla Research Award, UGC Career Award, Star Performer of IITR Faculty, Best Paper Awards by Railway Bulletin of Indian Railways, Special Facilitation in memory of late Professor M.C. Puri, AIAP Excellence Award. She has authored 2 books, supervised 20 PhDs, and published 125 research papers in reputed journals. Madam Kusumdeep is a senior member of ORSI, CSI, IMS, and ISIM. She is the executive editor of International Journal of Swam Intelligence in Science. Professor Kusum is an associate editor of Swam and Evolutionary Algorithms elsewhere and is on the editorial board of many journals. Madam is the founder president of Soft Computing Research Society, India. She is the general chair of series of international conference on soft computing for problem solving. Her research interests are evolutionary algorithms, swarm intelligence, and nature-inspired optimization techniques and their applications. We are eager to listen to your insightful speech, madam, on the webinar topic, Making Mathematics Interesting for Engineering Students. Over to you, madam.
Thank you so much for the kind introduction, and thank you so much for inviting me over to address these students. It is my pleasure. I usually am very fond of talking to budding engineers, and I see that the audience is quite in this line. So it's a pleasure to have you with me. I'll just share my screen, just a minute. Just give me a minute. Yeah, that's it. So I hope you can see my screen, everybody. Can you see my screen, please?
Yes, madam.
All right, wonderful. So let's begin off, and I'll be talking to you all about solving real-life optimization problems using nature-inspired optimization techniques. Now, first, let me ask a question to the young audience. What is the objective of any engineer? Yes, please. You can either type in the chat box, or you can unmute yourself and speak up. So what is the objective? The question is, what is the objective of any engineer? Yes, please. Okay, there are some questions. What is the objective of every engineer? Okay, to make things work the way we want. Wait, oh, that is very nice. I'm listening to, I can see many response, so that's very good. Let me just read a couple of them. First of all, okay, there are some thanks messages. Let me just go down. To get job, okay, that's very good. To make a better living, wonderful. To make our lives easier, to make things productive, any work to solve in technical way, to make life easy, to make life every individual easy, making humans, okay, that's very nice. To make life of every individual easier, to make life easy, to make life easy, okay, that's great. To live with technology, to make a good and technological society, something, okay, that's superb. So thank you so much. Thank you so much. So I would sum up with what you all have said. And the common thing is that the objective of every engineer is to make life comfortable for the common man by solving real life problems, right? That is what we should conclude from all the messages that we got. So that is exactly what I'm going to talk about. I'm going to talk about solving real life problems using nature-inspired optimization techniques. And I will show you that the maximum number of real life problems turn out to be optimization problems. So here is a sort of a flow of what I'm going to talk about. I'm going to talk about the optimization problems. What do you mean by optimization problems? And then I'll tell you what is the meaning of nature-inspired optimization techniques. And then I'll show you some of the applications of the optimization techniques into the real life problems. So here are a couple of, just some of the nature-inspired, some of the real life problems which I have tried to solve during my academic career. So that's very nice. So now before we begin, let me just show you a video. It's a small video and you will just enjoy this. Let me know if you can hear the sound also. So just like, if you don't listen to the sound, just give me a. Can you hear the voice?
No.
No, you can't. Oh dear, yeah, I'm so sorry. I think I should use some other option. I don't know what. Okay, well, there is some hitch, I think. Well, anyway, so this, what is this game? Do you know this game? What is this game? Yes, it's called the Super Mario. That's right. So I think everybody must have played this in your, game. This game in your life, in your school times or in your college times. So this is a game which is a simple Mario game. Now, have you ever wondered who has designed this game and who has coded this game, and how have they used any mathematics into it? The answer to this is yes. This has been designed by computer scientists who use a technology which is called as neuroevolution. So this is what it means. So here are there some keys, okay, and these keys are supposed to be pressed so that Mario can hit the targets. It's called a neural network. Probably you must have heard about what is the meaning of neural networks. It is a mathematical model, or rather a computational mathematical model, which takes as inputs a number of parameters and throws out another set of parameters. So here there are enemies or mushrooms which this Mario is supposed to hit. And that's the reason why neural nets are used to model it. Now, it's not the neural nets only, it is the evolutionary neural nets. So what is evolutionary neural nets? It means something which is, a model is designed at the first stage. The neural net is defined at the first stage. Then at the second stage, that neural net is modified like this over and over again. This neural net is trained based on the previous experience, and that is how the entire neural net, evolutionary neural net, is behind this design of this neural net of this game. So it is really interesting. You can know about the design of this neural net, evolutionary neural net, how it is used to design the optimized weights of this neural net so that it can play the game of Mario. So it's very, very simple, but you know, it's really challenging. Whoever has designed it with a lot of expertise, and that is what most of the computer scientists and engineers do. They try to solve something which is challenging. So you people over there, the young students, I motivate you to solve challenging problems just like this one, right? So here we go. All right, so now let's take another example. This example is something more relevant. You must have heard about the yeah, there it is, the 3D cars. You must have heard the cars, you know, these self-driving cars, very, very challenging. Here again, the neural nets are used to design the driverless cars. This is all optimization. This is all mathematics. This is all computer science. And it is a challenge for all computer scientists and engineers to think how the car is being trained with the help of a neural net. So here you can see it is first hitting the sides, sometimes the right side, sometimes the left side. And then it is learning and it is keeping a record of this information into its memory. And slowly and slowly, as the process is increased, it learns that, okay, this is a mistake I did in the last time. So therefore, I will not repeat this mistake. And finally, when you see, when the convergence takes place of the algorithm, then it becomes super fine. And here it is, there it is going. Okay, fine, it's going there smoothly. Finish, that's it. So this is the way the engineers have designed the self-driving cars. All right, so that's all about some examples. Now let's move on to some more serious work. Well, in order to know more about my work, you can look at these links. Now, let us first of all know what exactly do we mean by an optimization problem. In general, we can say that any function of n variables, let us say x1, x2, xn, which is a real valued function, can be minimized or maximized. And we are interested in determining those parameters of x1, x2, xn, those parameters x1, x2, xn, in such a way that the value of f, that is fx, this fx is minimum or maximum, of course, depending upon the problem. So if the problem is a minimization problem, then we are looking for a minimum of fx. If it is a maximization problem, then we are looking for maximum of fx. In general, this value n could be any positive integer greater than or equal to 1. These are called the decision parameters. And these parameters could be subject to a number of inequality or equality constraints, as is shown here. That is the g1x, g0x greater than or equal to 0, g1x greater than or equal to 0, like this, gmx greater than or equal to 0, etc. Similarly, there could be equality constraints, that is h0x is equal to 0, h1x is equal to 0, hlx is equal to 0. So in general, there could be inequality as well as equality constraints on these decision parameters x1, x2, xn. Apart from this, we have a specialized kind of lower and upper bounds, which are usually written separately for many reasons. Maybe we can discuss later on also as and how we move. In general, this f, the objective function, this is called the objective function, whatever is to be minimized or maximized. The g's and the h's, they are in general non-linear. They may be linear as well, but they are allowed to be non-linear as well. What is a non-linear function? Any function which is not of the type ax plus b is equal to 0, that is in one variable. Similarly, a1x1 plus a2x2 plus an(xn) is equal to c. This is a linear function in n variables. So anything which is not a linear function is a non-linear function. All right, now coming to the solutions. Now there are two categories of solutions. One is the local optimum solutions, that is those solutions which are minima in a particular domain, let us say a particular neighborhood of a point. So if there's a point x bar belonging to the search space, then if there exists epsilon neighborhood such that f of x is greater than or equal to fx bar, for each x belonging to that search space intersection with the neighborhood, then we call it as a local minima. And the other category is the global optimum solution, which means that this inequality should be satisfied in the entire search space. A hypothetical example can be illustrated in this figure. Here we can see that there are a number of local minimas, as you can see. This one is global, this one is local, and there are number of local minimas which are equally, closely placed near each other. Okay, so there are so many local minimas over here. There is a local minima here, but this one is the global. The reason is that this is the best in the search space. Apart from this, there is also a point which is called as the stationary point, where the necessary condition of optimality is satisfied, but not the sufficient conditions. Okay, so this is a hypothetical example to illustrate this. I think there are some questions. Let me look at some questions. Right, so okay, so I think there are some questions regarding the previous talk. All right. Right. So now another illustration is about the local and global optimum solutions. It can be seen here that if there is a two variable problem, I mean x versus y, so suppose x1, x2 or x comma y, and on the vertical axis we have the objective function. So here what we find is that here is a surface which demonstrates the heaps and valleys, indicating the local and the global optimum solutions. Now, in general, there could be various kinds of complexities arising in the objective functions. So here, just look at this problem. It's called the Eclat problem, and you find that there are a number of terms, and this is an n variable problem. And the n could be any positive integer greater than or equal to 1. And as and how the value of n increases, the complexity of the problem also increases. For n is equal to 2, this problem has infinitely many local minimas. And for n is equal to 2, this is what the surface of the objective function looks like. Another problem of the same category, these are called scalable problems, because the dimension of the problem can be increased as and how the user wishes. And of course, the complexity of the problem increases as and how n increases. This Rosenbrock problem is another interesting problem because it has a different kind of a complexity, which means that this problem is a unimodal problem. And as you can see, that it has a saddle point. So at the saddle point, the necessary condition of optimality is satisfied, but the sufficient condition is not satisfied. And finally, the shuffle problem is a non-differentiable problem because there is a absolute value sign under the root. Like this, there are other many interesting objective functions which people have defined in literature, and you can see that in most of these problems, the local and the global minimas are really looking weird, and it is difficult to find these local and global minimas. Excuse me. So now coming back to our real life problems, we are interested in solving real life problems arising in various fields of science and engineering and economics and business and finance. And therefore, we are looking for computational algorithms which can be implemented on the computer so that we can solve these real life problems with the help of an efficient and reliable computational technique. So what are the characteristics of real life problems? In general, the real life problems may not be differentiable, because when you're talking about a real life situation, it's not even necessary that the problem is continuous. So therefore, you have to keep in mind these characteristics of the real life problem. Similarly, the search space could be discrete, it could be discontinuous. And also the variables could be discrete, they could be continuous, they could be permutation type. And also the dimension of the problem could be extremely large. For example, there are problems in which the number of decision variable goes up to 1 million, okay, and even more. So that is the place where the engineers have to think of designing some kind of optimization techniques which can take care of such large dimensions. Of course, another situation arises when there are more than one objectives. This is really a challenge, because suppose you have, let's say you want to buy a car, okay, and you say, I want the car which is giving me the least cost. But your other family member, your brother, says, no, I want a car which is giving me the maximum efficiency. So like this, there are two objectives for buying a car. And this is the typical situation of a multi-objective optimization problem. And usually it is said that most of the real life problems are multi-objective in nature. Now coming to the literature review, there are two types of optimization techniques. One is called the deterministic approach, and the second is called the probabilistic approach. In the deterministic approach, there are set transition rules, which means you start with the initial guess and keep on updating that initial guess at each iteration. Whereas in the probabilistic approach, you keep on generating randomly generated feasible solutions in the search space, and as and how the generations proceed or the iterations proceed, you keep on updating that sample of solutions. Usually the deterministic approach methods are very easy to apply because they depend upon a formula, but they are applicable to a very restricted class of functions. As I said, they are applicable only to differentiable functions. And in general, in reality, you may not be having a function which is differentiable. So therefore, the probabilistic techniques are coming into existence, and people are using new and new probabilistic methods to solve their optimization problems. Okay, so let me just again look at the chat box. There are some questions in the chat box, which
somebody's asking saddle point, I think.
Yeah. Okay, saddle point. So what is the saddle point? Let me go back to the slide that I showed you about the saddle point. Yeah, there it is. Here is the saddle point. See, what is the condition of optimality? The condition of optimality means minima or maxima is that the first derivative should be equal to 0, right? Remember when we had a nonlinear function in our 10th class, we had a nonlinear function. We first took the derivative and put it equal to 0. This is the necessary condition. Okay. But in order to know whether it is a maxima or a minima, you have to take the second derivative. This is a sufficient condition because if the second derivative is greater than 0, then you have a minima. If the second derivative is less than 0, then you have a maxima. However, the saddle point is such a point at which it is neither minima nor maxima, but the derivative is 0, right? So that is what you mean by a saddle point. Is that okay? Have I made myself clear?
Yeah.
Right. Okay. Thank you.
Stationary point.
Sorry?
Somebody's asking stationary point.
We call it as point of
stationary point is the same thing as the inflection point of inflection.
Yeah, ma'am. That's what I would like to add. That can we call that as a point of inflection? That is a synonym of point of inflection.
Both names are usually used. You know, both names are there. Stationary point or point of inflection. It's the same thing.
Ma'am, but in case of point of inflection, it may be that I'm just updating myself. In case of point of inflection, it is that in some of the cases there may be that derivative is not 0. Then also function can have a point of inflection over there. Like for example, in some of the cases I used to taught for engineering aspirants. In that case where the derivative is exactly not 0.
Then what do you mean?
The saddle points are those points basically where the curve is changing its concavity from concave upwards to concave downwards, or concave rightwards to concave leftwards. Ma'am, is it essential the derivative is 0? It can be the derivative is not 0, or I must say the derivative is not defined.
Well, that's another thing. See, if the derivative is not defined, then it's a different category. Right now, I'm showing in this curve, in this slide, what I'm showing is that this is a continuous function, okay? And over here, we are having a local maxima. Here, we are having local minima. Okay, but here, this is neither a minima nor a maxima. That's what I'm trying to say.
Okay, sure.
That's all that I'm trying to say. Because here, the first derivative is equal to 0, but you cannot say anything about the second derivative.
Ma'am, actually, yeah, that's very great, ma'am. Ma'am, what I used to teach, but let me make myself clear. What I used to teach is that the saddle point or point of inflection has nothing to do with the first derivative. I know I may be wrong somewhere. What I have a perception over this is that the saddle point or point of inflection has nothing to do with first derivative. Actually, they are completely dependent on second derivative that we call as d2 by over dx2.
Yeah. Well, we can discuss on that analytically, but this is just a simple illustration to exhibit to the students that I am talking about local minima and local maxima and global minima and global maxima, and this is a point which is none of them.
Okay, thank you.
Right, that's all. Okay, thank you. All right, so now let's proceed further to, So as I said that we are now going to look at our focus on the probabilistic approach. Now, in this probabilistic approach, there are a number of methods which have been proposed over the last couple of decades. And these previous methods, the deterministic approach methods, are using the differentiability conditions. In fact, the second derivation differentiability conditions as well. But in the probabilistic approach, this differentiation property is not required. And that is the reason why they are becoming more and more popular, and more research is going into it. The other names for these kind of methods is called as stochastic methods, or meta-heuristics methods, or population-based methods, or nature-inspired methods. Here is a general classification of some of these methods. Of course, some of them are overlapping, and one can, talk about the different categories. This is a partial list. Of course, it's not a complete list. This is a partial list because this is a research area which is ever growing every day. And there is a lot of scope of research in this area to design new nature-inspired optimization techniques with a view to apply them to solve real-life problems. Now, as I mentioned, that there are a number of differences between the traditional techniques and the nature-inspired techniques. The nature-inspired techniques, they search from a population of solutions instead of a single solution. Let me illustrate this with the help of an example. Now, here again, this is a hypothetical example. Suppose we have a curve like this, okay? And we want to find out that x for which fx is the least. We want to find a minima, right? So we can see here that this x2 is the answer, is the solution to the problem. Okay, it's just a hypothetical function, just bear with me. This x2 is the solution. Now, in order to reach to this solution, what I'm going to do is, I'm going to start with the initial guess, randomly chosen initial guess, x0. And this x0 is going to be called as the initial guess. Yes, there is a question by Siddharth. Yes, please. Can you unmute yourself and tell me what you want to ask? Yeah. Siddharth, you want to ask some questions?
No, I think by mistake he must have raised the...
Okay.
Yeah.
All right. Okay. So starting from x0, we will use some analytical formula, depending upon the technique that we're going to use, to get another point, which is called as x1. Sometimes we use, let's say, the Newton-Raphson method. So from x0 we will come to x1, then we will come to another point, and then another point, and finally we will come to the optimum. Usually this is done in a couple of steps. Okay, of course, provided the mathematical conditions are satisfied. I won't go into the details of that. But for example, the Newton-Raphson method, in the Newton-Raphson method, we start from here and we keep on moving to the final solution step by step from one point to another point. This is the normal way the Newton-Raphson method works. But the probabilistic techniques or the nature-inspired techniques, they generate a random sample of solutions in the search space. It's very simple to understand. Let's suppose you generate 3 points in the initial population and keep on applying more and more iterations such that these solutions, they converge to each other. Let me look at the next generation. This is the next population. Here you will see that these points have come closer. See how they have come closer. Don't worry about that. That is the job of the nature-inspired technique that we're going to work. So what I'm trying to tell you is that starting from the initial population, that says you've chosen 3 randomly generated points. Now we will come to the next population by applying some operators in such a way that they come closer to each other. This process will be repeated over and over again, let us say in k number of iterations. This is the philosophy behind the nature-inspired techniques or the population-based techniques. All right. In order to understand this concept in a better way, let me just illustrate with the help of a two variable problem. So suppose you have X versus Y. This is the feasible space. X versus Y. There are two variables. And this red dot over here, this is the solution. Okay. Now I'm going to generate 10 randomly generated feasible solutions. And I'm going to evaluate the objective function at each of these points. And I'm going to apply the operators of my nature-inspired optimization technique. So don't worry what those operators are at the moment. And see what happens in the third generation, fourth generation, fifth generation, sixth generation. And like this, when the convergence takes place, all these solutions have converged to very, very close to each other. And this is the principle behind all nature-inspired techniques. All right, so the nature-inspired techniques uses objective function information instead of the derivatives. And the nature-inspired uses the probabilistic transition rules. See, there is no mathematical theory behind the convergence of these methods, but they converge to the minima in the probabilistic sense. That is, as limit generation goes to infinity, all the solutions, they converge to the minima. And people have tried to use the Markov chain process, etc. Well, you don't need to go into that. The beauty is that these techniques can be applied to discontinuous functions and non-differentiable functions. And as you know, that real life problems do not guarantee that the functions are continuous or they are not even differentiable. So they have a very wide applicability. And these techniques are very simple to program. Anybody with a simple knowledge of computer programming can code them and solve their problem. Now, coming to the classification, there are 4 categories, I would say, of these nature-inspired techniques. First is the evolutionary algorithms. Second is the swarm intelligence-based algorithms. Third is the algorithms based on physical laws. And the fourth is the miscellaneous category. Now, the first category, that is the evolutionary algorithms, has genetic algorithms, differential evolution, evolutionary strategies, genetic programmings, etc. These algorithms are based on the Darwin's theory of evolution, which has 2 properties, the property of inheritance and the property of competition. This is the picture of Darwin over here down below. And you know what is inheritance? Just like you inherit some money from your mom, dad, exactly you inherit some good properties, let's say intelligence, beauty, all these are good traits. So you would like to inherit these good properties from your parents. Exactly in the same way, the genetic algorithm tries to inherit good traits. By good traits over here, we mean if a feasible solution is good in the sense it is close to the minima, then that solution will be given preference and priority to move over to the next generation, Similarly, the second property is the property of competition. So what is the property of competition? You see, life is a race. They say in that 3 Idiots, they say life is a race. Everywhere you have to talking about competition. When you are in school, mom, dad says, look, your neighbor is getting so much good marks, you are not getting good marks. Then when you get into college, you get into university, oh, your friend is getting good marks, you're not getting good marks. Then you start a good job, then again, oh, look at him, he's got such a big salary package, you're not getting a salary package. Then he's got a good girlfriend, I've not got a good girlfriend. Okay, beautiful girlfriend, and that I have got more girlfriends, she has got less girlfriends, right? He has got less girlfriends. So everywhere there is competition, and the one who is more fit will survive. So this is the competition is nothing but the survival of the fittest. Whosoever is having better fitness will survive, and the rest of us will die. For example, in today's scenario, they say that those individuals who have high immunity, they are going to survive, and the rest of us might die. So the survival of the fittest is the talk of the day. Yeah, I think there is somebody, Ritnesh Maurya. He has raised a hand. Yes, please, Ritnesh. Can you please unmute yourself and tell me what you want to ask? Ritnesh, you want to ask something? Ma'am, please share the PPT.
Maybe by mistake, madam.
Okay. No
maybe
problem.
he may be from first year, recently joined student.
All right. So. Okay, no problem. All right. So this is the famous Darwin's theory of evolution. You must have heard about it in the news, in the TV as well. That this Darwin, he proposed this theory of evolution millions long ago. Okay, and this two properties is the basis of genetic algorithms. Now let's come to the success stories. You must have heard about the bullet train, which is the talk of the day these days. Particularly our country is also in the process of designing high-speed trains, bullet trains. Now, have you ever imagined how this design of the nose is taking place? It's a highly complicated problem. And you engineers, you people like engineers, are the brains behind designing these bullet trains. One of the Japanese website has mentioned that genetic algorithms has been used to design these bullet trains, the nose of these bullet trains. And of course, I believe this is a multi-objective optimization problem, because you have to keep into mind a number of parameters, number of constraints, etc. All right, now let's come to the second category of algorithms. Swarm intelligence algorithms. What are these swarm intelligence? What is swarm intelligence? Swarm is a group, okay, and intelligence means with respect to human beings, they are intelligent, but not as intelligent as human beings. You must have heard about the birds who are flying in the sky, and they all fly in the sky in one direction. There is some kind of communication which is taking place between these birds. What is that information sharing property is really remarkable. And this is what has been incorporated into the particle swarm optimization, the gray wolf optimization, artificial beacon. There are many of these swarm intelligence algorithms. Okay, and the properties are that they all fly together, right? And they do not leave their group, and they do not collide amongst each other, and they all know where to go. So this is what is the behavior of swarm intelligence based algorithms. Third category is the algorithms based on physical laws. The law of gravity and the central force optimization. These are the just a couple of them I have mentioned. In the miscellaneous category, we have harmony search algorithm, which is an algorithm based on the design of music. And biogeography based optimization is an algorithm which is based on immigration and emigration of living species. So all living species, they would like to go to those islands which has much more job opportunities, for example, and they would not like to go to a place where there is nothing to do. There is no livelihood. So there are some laws behind the immigration and emigration, and your biogeography based optimization is based on that. Similarly, the sine cosine algorithm is a simple algorithm based on the sine cosine functions. The tug of war optimization is based on the tug of war game that you used to play. Water drop is another algorithm, teaching learning based algorithm, many of them. All right, so now let me just take you through over the history. Initially, the Monte Carlo simulation came into existence, where on the computer, randomly feasible solutions were generated and they were examined whether they are good or not. Then came the random search technique, which had two phases. In the first phase, a number of randomly generated feasible solutions were generated. And in the second phase, these points were manipulated to get a better search. You must have heard about the way the ants, they travel. Usually they follow each other like this in a line. And have you ever wondered what communication takes place between these ants? Usually they leave a perfume which is called as pheromone. That pheromone helps the follower to know where I have to go. And this is the reason why these ants, they follow each other. Now they are intelligent creatures. Ants are very intelligent creatures because as and how an obstacle comes into their way, they choose the shortest path. As you can see in this diagram, they choose the shortest path. This kind of ant colony algorithm is indeed a very interesting inspiration for the design of ant colony optimization, which is proved to solve a number of discrete optimization problems. I mentioned about genetic algorithms. So genetic algorithms is one of the most important evolutionary algorithms. Holland is called the father of genetic algorithms. It is based on the evolutionary process. As you know, the life began on the earth with a single cell amoeba. Slowly, over the millions and millions of years ago, it became more and more complicated. Today, we are human beings. And tomorrow we might end up with superhuman beings with some antennas on our heads. Now, what is the cycle, one cycle of a genetic algorithm? It is very simple to understand. Initially, these randomly generated feasible solutions are determined in the search space, and they are evaluated using some fitness criteria. That is the objective function. Then a subset of these solutions are chosen, and the crossover operator is performed, which is the property of inheritance. Then the children are obtained, the children solutions are obtained, and finally the mutation is done. And this is how one cycle of a GA is organized. Repetitively, this process is repeated till the stopping criteria is satisfied, and that's how the solution is obtained. Okay, so this is just the previous one, what I was mentioning. So these are the operators of a generalized genetic algorithm. Encoding is a one-time operator because encoding helps you to code your problem either, let us say, in binary form, let us say 0-1 kind of a form, or it could be a permutation, that is, ordering problem. And then there are these operators which are repetitive operators. There are many kinds of selection operators. Tournament selection is one of the most common ones. That is, you play a tournament just like you have the cricket matches. So in the cricket matches, you play tournaments between each couple of them, and the winner is placed in the mating pool. Similarly, over here, the winner is placed in the mating pool, and then there is a tournament between these. So exactly in the same way, we will generate randomly generated feasible solutions in the search space and play a tournament between each of them and put them in the mating pool. Then comes the roulette wheel selection. In the roulette wheel selection, again, you spin a wheel just like in a casino, and wherever the arrow stops, that is the place where you have to pick up that individual. Now, there are many kinds of crossover operators depending upon the encoding that you are doing, whether it is binary or real, etc. Similarly, the mutation operators is dependent upon the kind of encoding that you have used. So the generalized.
Madam, sorry to interrupt, Madam. Siddhant has asked some question.
Yeah.
It's in chat box.
Let me just see it. Yeah. Okay. So, ma'am, if we by any method remove pheromone left by ant, then what rest ants will do to reach their destination? Dear, we cannot do anything. What these ants are doing, they are very intelligent creatures. They are leaving this. This is a natural phenomena. They are leaving that pheromone behind each of them. Okay, and that is how they know where to follow, which path to follow. So this is a natural phenomena which the ants are doing. We cannot control them. Okay, and this is actually, we are using this property of the ants. This is what we are using in the ant colony optimization algorithm. When we design the ant colony optimization algorithm, this is what we use. So we don't want to change it. I mean, whatever is nature, we can't change the nature, and we should not change the nature. This is the nature, and we are taking our inspiration from the nature. Thank you. All right, so pseudocode of a GA looks like this. Generate an initial population of randomly generated feasible solutions and repeat these crossover operators, mutation operators till the stopping criteria is satisfied. Also, there came into existence the real coded genetic algorithms, which were based on the real encoding. Then they came the memetic algorithms. These are algorithms which incorporate some local search into the genetic algorithm with an objective to improve the search, to refine the algorithms and improve the search. This refinement of or the incorporation of local search can be done at many places, not only at the beginning, but in the inside a big loop also. Self-organizing migrating genetic algorithms are those algorithms which derive their inspiration from the self-organizing maps or patterns that we find in nature. You must have seen the Fibonacci series. The petals of a flower, they follow Fibonacci series. These kind of patterns in nature are inspiration for we people to design optimization algorithms. Now, coming to the Swam intelligence again, let me just again share with you a small video in order for you to understand what is the meaning of Swam behavior. So here you will see that birds are sitting on this tree, and as and how I click this small click of video, these birds will start flying in different directions. Early in the first stage, they will fly in different directions, but slowly some communication will take place between them, and we will find that all of them will start moving in the right direction, towards this direction. Okay, and this is what is called as Swam intelligence behavior, because after some time, these birds, some amount of communication has taken place between these birds, and they are saying, okay, chalo idhar chalte hain, we'll go towards this side. So very interesting to watch a small video clip. Just look at it carefully. Right? So you observed, I hope you observed that in the beginning, all of them were flying in different directions, but very soon they all started moving in the right direction. All right, another small video clip to illustrate the swarm behavior, how these birds are interacting amongst each other. Just look at this. So yeah, that's it. So these birds are communicating amongst each other. Abhito, there is the red signal, don't cross the road. Moment the signal is green, they all started moving. So they have communicated amongst each other. We don't know how that communication has taken place. Exactly in the same way, we will incorporate this, this phenomena into our optimization algorithm, that now we have to move towards this direction. Coming to some success stories, you must have heard about the drones these days. The drones, they play a very vital role, not only in defense, but also in civilian problems, let's say relief to flood hit areas or agriculture or tracing the wildlife and so on. So here again is a very small video to illustrate that swarm drones are a group of drones which work on the principle of particle swarm optimization. That is, there is no human intervention between these drones, so that they can collectively start from their position and finally they will hit the target. So a small video to illustrate this concept. So the engineers like you are the brains behind the design of these kind of swarm drones. In fact, one of my projects with some of my groups is to design these swarm drones for defense purposes. Of course, that's all confidential, but anyway. So I just want to motivate you that young engineers are welcome to try their hand at the design of swarm drones using particle swarm optimization. Now, coming to particle swarm optimization, as I said, these are the two gentlemen who designed the particle swarm optimization in 1995. And it has two governing equations where the velocity of each particle is updated based on its current position, the difference between its current position and the personal best position over history and the global best position over history. The second governing equation is the position update equation. So the position of every particle is updated using these two governing equations. That's the pseudocode. You can just skip that. Coming to artificial bee colony algorithm, this is an algorithm which is based on the honeybees, how they work. And the two properties is the self-organization and division of labor, which means that the honeybees, when they live in a hive, they know that who has to do what. This is the hive, and you can see that the honeybees are of three categories: the employed bees, the onlookers, and the scouts. Accordingly, these three types of bees are assigned their jobs, and their objective is to produce nectar from the food, from the flowers. Then there came the firefly algorithm by Xin-Shi Yang. This is based on the light intensity or jugnu, जिसे बोलते हैं हमारा firefly are the jugnu, and because of this, the distance between the light source is inversely proportional to the intensity. Then cuckoo search is also a very important algorithm, which is responsible for these two basic mechanisms, the intensification and the diversification. Of course, you don't need to go into that. Then came the gray wolf optimization by Mirjalali et al. In 2014. This is the hunting behavior of gray wolves. They live in a pack of wolf, and their objective is to kill their prey. So they all live in a hierarchy. Alpha wolf is the best wolf, and like this. So the mathematical model is designed like this, and we set up a vector like this, and in this way, well, don't go into the details of it. These are the governing equations. I can just skip this. Now the question is, you would say, which algorithm is the best? And the answer to this is the no free lunch theorem. This theorem says that there is no one single meta-heuristic which is best suited for all optimization problems under the sky, which means that since the complexity of all optimization problems is of varied kind, at some places there is a saddle point, at some places there are multiple minimas, and so on. Therefore, it is not possible to design one single optimization algorithm which will solve all optimization problems of varied kinds of complexities. And that is the reason why scope of research, there is a lot of scope of research in this direction. And if I have been able to motivate you to develop a career in this research area, I will be very happy. Just like you cannot have one single medicine for all diseases. If you have heart problem, you have to take different medicine. If you have diabetes, you have to use different medicine. Exactly in the same way, the no free lunch theorem works. Now, coming to some of the applications to real life problems, which me and my students have worked out. This is a problem to build a better air defense system. Here we are supposed to, this was a problem with the DRDO, the Defense Research and Development Organization. So there we identified 3 types of weapon systems, and we were supposed to protect the assets from the enemy. So for this, we model the problem as an optimization problem. That is the mathematical model for it. And there were some constraints in it, and we used genetic algorithms to solve it. Another interesting problem I want to share with you is a very simple problem, and I think many of you will be able to actually write a model for it. It's called the circle packing problem. The problem says that given an area which has a number of non-overlapping disks scattered over a surface as shown in this screenshot. So suppose in this screenshot, there are a number of circles of different radii and centers. Okay, these are given. Now the problem is you have to design one circle which should be of the largest area such that it should not intersect any of the given circles. Okay, it's called a packing problem. It's called a circle packing problem. So the problem that can be stated is find the disk of the largest radii which may be placed amongst these disks without overlapping any of them. Now the problem is very, very difficult. It's not easy to solve this problem. But the nature-inspired techniques, the genetic algorithm could solve this problem in this fashion. Hello? Yeah, I'm in a meeting. Can you please wait? Hello? Right. So this is the solution. And I encourage any of you participants, the students, to please look into the model. Just excuse me, I have a call, please. Sorry about that. I had a call. Right. So the question is, what is the use of this circle packing problem? The use is in the radiation treatment. You know, it's a very important problem for solving for the common man. Now, a common man is supposed to have, he may have this kind of a problem where, you know, he has a terminal disease. And you know, he has to go in for radiation treatment. So he has to expose the affected organ with radiation in such a way that the surrounding organs which are at risk are least affected. So here is an organ, and we are going to use the circle packing problem to apply the radiation treatment. Here comes the first shot, second shot, third shot, fourth shot, and like this. So the circle packing problem, which we just now looked at, has been used for the radiation treatment. So important for the general public. Then comes the word matching problem. This is a problem for the pattern recognition. So suppose there's a pattern, to be or not to be. You know, this is a simple pattern. It's a phrase, but in general, it could be a image. It could be a video or anything. And this target has to be matched with the input. And if you try to solve it in a random way, then the probability of getting the correct answer is very, very small, as you can see. But if you use a genetic algorithm, then the genetic algorithm will give you the results in just 23 generations. So here you can see in the 23 generations, we got the solution. This is a very simple problem because I used a very small 13 variable phrase, but the problem may be very, very complicated. And this is where the genetic algorithms and particle swarm optimization come into play. Then comes the design of timetable. This is a combinatorial problem. You have to make a combination that the subjects, teachers, and locations and time slots, there should be no clash. So suppose you use these statistics and you try to write a genetic algorithm like this. Of course, don't worry about it. And design the fitness so that there is no clash. And the clashes should be minimized. And like this, we can solve it. Okay, I think I can skip these highly technical engineering problems. And okay, here is a problem where the number of local minimas is 2 to the power 17. Look at this. This challenging problem has been solved by particle swarm optimization. Another interesting problem is the minimization of Leonard-Jones potential. This is also a very difficult problem where for an 8-atom structure, the surface of the objective function looks like this. Now, this is a problem which is related to bioinformatics, where the extraction optimization of bioactive compounds from various Indian herbs has to be performed. So suppose there are these bioactive compounds, and in the gardenia is a herb from which the medicines are prepared. This is what the gardenia looks like. And this is used in a number of medicines. In order to model this problem, we used 2 stages, stage 1 and stage 2, and we could get very excellent results, and we have filed a patent for it. Similarly, ashwagandha has 2 bioactive compounds, and we have to determine the parameters of this. This is what ashwagandha looks like. These are the 3 forms of ashwagandha, and it is used in major herbal industries. Again, we have modeled the problem as a multi-objective optimization problem, and again, the patent has been filed for this. Trim loss problem is also there. It is in paper industry, glass industry, or textile industry. That is, you have to minimize the trim. Whatever is remaining, that should be minimum, so that wastage is as less as possible. This problem is also modeled, and we have used PSO for it. Combinatorial problems are there, as I mentioned, lots of them are there. The traveling salesman problem, where there is a traveling salesman who has to visit n number of cities in such a way that he visits all the n cities without repeating any of them, so that this overall cost of traveling in each of the cities is minimized. Forecasting of avalanche is a problem which I did with the Defense Research and Development Organization, where we were supposed to forecast whether avalanche is going to take place or not in the next hour. So it was an hourly prediction, and we had to use parallel computing in order to get the predictions. The tool that we have developed, we use artificial bee colony algorithm. The tool that we developed is being implemented in DRDO, SASE, Chandigarh. Similarly, the seismology. The seismology is the study of earthquakes. This problem we did with the Wadia Institute of Himalayan Geology, Dehradun. You know that earthquake is consisting of the primary waves, the secondary waves, and the surface waves. And this problem turns out to be a nonlinear, highly nonlinear problem, which is dynamic in nature. And the forward problem and the inverse problem has to be solved in such a way that it is the least sum of squares. I mentioned at the beginning also, the least sum of squares, the calculated and the observed, calculated the travel times of the P waves is to be minimized. So with this, I come to the end of my talk. And if you are motivated and interested in reading these nature-inspired techniques and their applications, I invite you to read these books. Of course, this book is still in press. This book is there. He's my collaborator, Professor Xinxi Yang from Middlesex University, UK. His book is available online. Otherwise, you are free to contact me. Here are some of the journals which you can look at if you are interested in this topic, and some conferences. And of course, the Google Tips does the trick these days. These are some of the announcements I'd like to make. I'm the president of the Soft Computing Research Society. If you would like to become a member of this, you are welcome. Everything is online, and you have to make the payments online, and you will know once you become a member, you will automatically be added to our mailing list, and you will know about all our activities. One of the signature events of this society is SOCPRO series of conferences. We just finished it 2 days ago. I'm also the executive editor of the International Journal of Swam Intelligence and the series editor of this Algorithms of Intelligent Systems. So with that, I come to the end of my talk, and I would like to invite any questions from the audience. Over to you, please. Yes, please.
If anybody is having
Any questions, please?
Yeah, students, any questions? You may ask questions to both the experts.
Actually, madam has explained so nicely.
Yeah.
I think hardly there will be any query.
Yeah, there it was.
So I can see there are a number of messages just thanking
Yeah.
me. I would like to thank you for being a nice audience. And any questions you would like to ask, you are most welcome. In case you have any other questions, you can write a mail to me and I'll be happy to interact with you. Thank you so much and wish you all a good day.
Thank you, madam. Yeah. The power of mathematics is often to change one thing into another, to change geometry into language. Thank you, Professor Kusumdev, for your insightful presentation on the webinar topic. You are truly a motivational benchmark to the researchers and academicians, mathematicians, and students of the country. Thank you very much for your excellent and interesting delivery on making mathematics interesting for engineering students with nature-inspiring techniques and other techniques too. Thank you, madam. Let me ask director sir, he's also there with us. Sir, can I call you for concluding remark?
Okay, thank you, madam.
Yeah.
I'm here.
Yes, sir.
Yes. Well, we have just gone through the deliberations made by Professor Kusumdeep from IIT Roorkee. She has presented and elaborated the things in such a nice manner, and specifically taking into account the real life problems which are associated in the different fields. How the mathematics can play a role in different practical problems in day-to-day life, whether it is related to the defense, whether it is related to the drone and the other things, whatsoever it may be. So we are really thankful to Madam Kusumdeep for sparing her valuable time, and I am confident that our participants might have definitely benefited, and if they choose their career, particularly in the research, they will definitely it will help them to go for their research career and to choose their career for further studies and all that. And I'm thankful to the Mr. Dikshit also, who also explained the things very nicely, specifically from the point of view with the basic fundamentals. He told a number of times that if you are weak in fundamentals, it will not be good in your career. Understanding higher mathematics, basic fundamentals are to be very strong, which he always emphasized. I'm thankful to Mr. Dikshit also. I'm thankful to all the organizing team and the SPIU team for assisting in conducting such a nice national webinar, and all the participants who have been part of this. Otherwise, it would have been not as successful as it was, because I saw there were a number of the more than 250 or like 300 participants must be there on this platform. With all these words, I'm thankful to all of you once again. Thank you very much.
Yeah.
Thank you so much. Thank you so much.
You,
and
sir.
thank you for inviting.
Thank you, madam. Thank you very much.
Thank you so much. Thanks.
Madam, one question has arisen.
Please tell.
Yeah, how the hybrid evolutionary algorithms can be framed?
That's a good question. Who's asked this question?
Bill, I think from Singapore it is.
Oh, that's wonderful.
I don't know.
Actually, I'm so happy with this question. I would like to interact with you. Please write a mail to me, and I will tell you a lot about it. I have done a lot of work in this direction, but let me just sum up for the audience. Hybridization can be done in many ways. For example, if you have two algorithms, let us say GA and PSO, right? You want to hybridize them. You can hybridize them in a number of ways. For example, the initial population can be divided into two parts. On first part, you can do the GA. On the second part, you can do the PSO. That's one way of doing it. Of course, How you choose those two different populations or two subpopulations, that's also, it can be done in many ways. Either you arrange them in increasing order of objective function value and pick the good ones and the bad ones, or you pick them alternatively, good and bad like this. Secondly, you could hybridize them iteration wise. One iteration GA, one iteration PSO, right? And like this. Another way could be in the same iteration, first perform the GA, then perform the PSO, then perform the GA, then perform the PSO. So there are umpteen numbers of ways in which hybridization can be done. It's a very interesting question, and I'm very happy a person from this audience has asked me this question. It really shows that my lecture has been very, very successful. Thank you so much for asking this question.
Thank you, madam. Yeah, thank you.
So please write a mail to me. Please write a mail to me.
Yeah, thank you so much, madam.
Thank you.
Yeah, let me take this privilege to propose the vote of thanks. We are at the end of the session now. I wholeheartedly express my gratitude to our chief guest today, Engineer Rakesh Gupta sir, Honorable BOG Chairman, BIET Jhansi, our experts, Engineer Kumar Gaurav Dikshit sir, Director, Elite Institute of Mathematics, Gwalior, Professor Kusum Deep Madam, Department of Mathematics, IIT Roorkee, for sparing their valuable time and enlightening us on the webinar topic and giving the insightful aspects of the webinar topic. I am thankful and grateful to Professor V.K. Tyagi, Honorable Director, BIET Jhansi, and Dr. Anil Kumar in absentia, State Project Administrator, State Project Implementation Unit, Uttar Pradesh, for their constant support, motivation, guidance, the way they work beyond hours, and above all, showing strong faith on me by giving the responsibility to organize such important webinars during this pandemic by accepting with my virtues and defects. I must express my gratitude to Dr. Mahavir Singh Naroka, Nodal Officer Academics, SPIU Uttar Pradesh, and Dr. Atul Kumar Dwivedi, my colleague from BIET Jhansi, for their wonderful cooperation. I am thankful to all the members of SPIU team, all the members of my organizing team, and dear participants across the country from various states of our country. I must thank Almighty for smoothing my way by removing the hurdles whatsoever in my path and making the task successful. I must thank, if I must have left anybody to mention, I am thankful and grateful to all those who have directly and indirectly cooperated to this webinar. Thank you so much.
Thank you so much. Thank you so much. Have a good day.
Thank you, sir. Thank you, Kumar sir. Thank you, Director sir. Shall we end the meeting, sir?
Thank you, madam. Yes.
Yeah.
Yes,
sure. Yeah.
Sure.
Dear participants, I have shared the feedback link quite a lot time. If all of you have taken care of it. If not, I will once more share, and within 2 minutes, then we'll leave the meeting.